Hey everyone, this is Wakas with MobileSentrix. I would like to first and foremost thank everyone for supporting Ampsentrix to the journey that it's grown. The support that everyone's given Ampsentrix has been tremendous. So I'd like to go on a little bit of a journey how Ampsentrix came about. We saw that there was a demand in the market for a higher quality battery. All the batteries being offered in the industry were subpar. Batteries is a very sensitive topic for MobileSentrix. We see it as, hey, this is a critical part of a device that's actually going to be detrimental if it's a cheaper quality. In the aftermarket realms, when it comes to batteries and LCDs, an LCD could have a small issue where it blacks out, but there's no physical harm done to the device, the user, or the environment around it. Batteries, on the other hand, can cause harm to the end consumer. The one thing that we've faced with Ampsentrix is there's a rally of other distributors that have come out and been claiming to be at par with Ampsentrix, and they've always been adamant on saying that they can be 50 cents, $1 cheaper. The truth is that pricing sometimes deters a shop owner to might say, hey, my other supplier offers a product that might be a little bit cheaper that claims to be the same thing. But the biggest issue for MobileSentrix isn't that we're trying to price match a competitor, but is to educate the shop owner to ensure that he understands what product is he selling and what product is he going to put in the end consumer's phone that could theoretically damage his device. Over this last 2 years, we've been trying to come up with a solution to see if there is cheaper alternative batteries that can be offered by Ampsentrix. And anywhere we looked, we've just found so many holes and problems with these aftermarket batteries. That's brought us to a point that we're saying we need to give store owners a cheaper alternative, but at the same time educate them on knowing what they're buying. So after 2 years of hard work, we're proud to introduce Ampsentrix Basic. To make it less confusing, we've decided to upgrade the name from Ampsentrix batteries to Ampsentrix Pro. The term Basic might actually say that it's too cheap of a quality of a battery, but that's where I feel first thing that we need to do is educate everyone on what have we done and what's our end target. I'd like to take a few minutes to go over what is currently offered in the market, what is Ampsentrix Pro, and what's Ampsentrix Basic. Once you have fully understood what separates Ampsentrix Pro from Ampsentrix Basic, and then what separates Ampsentrix Basic from everything else being offered. So bear with me a few minutes while I go over all these points. The battery can be tested by 8 main components that define the structure. Battery core, MCU, temperature control, gasgate chip, voltage resistor, protection IC, FPC connector, CPU communication. I want to break each component down into 3 parts. 1, the importance and function. 2, the market availability. And 3, battery comparison. So today we have 6 samples of iPhone 11 battery for the battery comparison. The original, the Ampsentrix Pro, the Ampsentrix Basic, XCAP, Utopia battery, power cell. The testing results will be given a score and then graded for comparison. Let's dive deeper into the first part, battery core. A lithium-ion battery core is just made up of an anode and a cathode layer that's separated by a film. Mobile phone batteries have 2 main battery assembly processes. First, the winding battery structure, where there's 1 long anode and 1 long cathode layer, and they're separated by 2 separator layers and wound tightly till they have a desired flat. Second, the stacking battery structure. And this is where a shorter anode and a shorter cathode layer have a separator layer to complete the multi-layer lamination structure. Stacked batteries could have a Z separator layer or a single film separator layer. Energy density, stacking batteries will have a higher density because they can utilize more space. Winding batteries will have a lower because they will have a C angle, and the larger the capacity, the lower the utilization rate. Faster charging. Stacking batteries are definitely faster in charging comparative to the winding battery. Life. The stacking battery will have a longer life because it has lower internal resistance, and the winding battery will have a shorter life because it's easy to deform in a later stage, which in turn affects the life cycle of the battery. Production. The stacking battery is much slower. It can produce about 6 to 8 pieces per minute, where the winding is much faster. It can do about 12 to 13 pieces. As far as the shape's concerned, stacking batteries can get into any shape they want. L shape, question mark shape, any shape that's desired for the device. And winding batteries can only be flat or a round shape. But when it comes to process maturity, stacking is much lower. The number of poles is large and the investment in the equipment is much more. The process for the winding is much higher because there's fewer pole pieces and the maturity of these equipment is much more mature. Apple uses stacked batteries from these models, but starting from iPhone 13 and forward, all batteries have been stacked, even the flat-shaped batteries. But when it comes to aftermarket batteries, only the L-shaped batteries will utilize the stack format, and the I or flat-shaped structure will use the winding technology. We can see from this chart that the OEM batteries take advantage of the full capacity from iPhone 13 and going forward, and the aftermarket batteries, even the Ampsentrix Pro, will try to produce a battery that is production efficient. The gas gauge IC is essential for managing a battery's power. It performs 5 critical functions. It calculates the remaining battery capacity and communicates this to the device. It determines the required wattage for charging the battery cell. Often integrated with the temperature sensor, it relays temperature data to the battery's MCU. It logs historical data to track and report battery health degradation. It monitors the battery's cycle count, which means how many times it has fully charged and fully discharged, making one cycle count. The evolution of the gas gauge chip over the past 10 to 15 years has been remarkable. For Apple, the journey first started with the iPhone 4 battery having a 7541 Ti chip. This was a basic chip that monitored the battery's health, but was very high in resistance. The capacity calculation was delayed and sometimes would cause the device to show a jumping percentage when it goes below 10%. I'm sure a lot of you remember those days. iPhone 5 through iPhone 6 Plus introduced the 27545 Ti chip, which solved the jumping issue of the predecessor Ti chip, but still had delays in the capacity calculations and still a very high resistance. Ti followed up by introducing a newer chip, 27546A1 and A2, which was used in the iPhone 6s through the iPhone 7 Plus. This solved the high resistance issue for the previous models. When iPhone 8 was released, they had solved all the prior problems and developed a 27546A3 through A5 Ti chip. This was a game changer for the speed of calculation, and resistance was also lowered again. And this chip was used till the iPhone XS Max. From the iPhone 11 onward, the SN7037 chip revolutionized the voltage management and communication between the device and the gas gauge chip. Now, looking at the progression from the iPhone 4 to iPhone 15, we see a clear evolution in the gas gauge technology. We can now combine this knowledge with what's being offered by Ampsentrix and the rest. Now, this test being performed is being done with an iPhone 11, which should be comparable to anything newer being offered by Apple. When we look at Ampsentrix Pro, it harnesses a 7037 chip, same as the original iPhone 11. Ampsentrix Basic uses a 27546A3 chip. We look at this Utopia board and we see it's using 27545. Now this is the same as the iPhone 5 through the iPhone 6 Plus. A little bit old technology, but still a Ti chip. XCAP, on the other hand, it uses the very original 7541 chip. This was used in the iPhone 4 and 4S. Very old, many issues, just a poor Ti chip. And PowerCell, on the other hand, doesn't even have a Ti chip. Can't even put this on this chart. Effective temperature control is vital for battery safety and lifespan. It's about keeping an eye on the battery's internal temperature, ensuring it doesn't overheat or experience thermal runaways. This regulation is key to preventing potential hazard and prolonging battery life. Most gas gauge chips, especially those from Texas Instrument, come with the built-in temperature control features. When a TI chip is compatible with the host device, the gas gauge chip can directly communicate the temperature data to the CPU. In cases where the aftermarket battery uses a TI chip different from the original, an MCU chip is typically added to the battery BMS board. This MCU acts as an intermediary, emulating the functionality of the original chip and relaying temperature information to the CPU. Typically, an Apple battery has at least 2 temperature sensors. going up to 3 for multi-cell configurations like the iPhone X. Apple design philosophy aims to keep the battery temperature below 55 degrees Celsius, a standard for safety and efficiency. In our comparison of various suppliers, we specifically looked at how batteries manage temperature during charging. For instance, the Ampsentrix Pro begins at around 36 to 37 degrees Celsius and gradually increases as power is applied. As it nears 55 degrees, it also will reduce the temperature. Similarly, Ampsentrix Basic also regulates its temperature upon reaching 55 degrees. On the other hand, we've noticed that other brands like XCAP, PowerCell, and Utopia often provide misleading temperature data to the motherboard. This deceptive practice allows them to charge faster by drawing more power, but it's detrimental to battery health and safety. In extreme cases, such as battery explosions, these batteries might continue to draw power, worsening the situation due to the lack of accurate temperature feedback. The resistor adjacent to the cascade circuit is a crucial safety component. It protects the IC from overcurrent and electrical interface, ensuring the battery's monitoring system remains accurate and reliable. This protection is key to effective battery management and overall safety. Resistors are often marked with codes like 010 or 005, indicating their resistance value, which directly affects the voltage transferred within the circuit. The smaller the resistor, the less the markings due to the size constraints. For instance, a 005 marking implies an internal resistance loss of 5 milliohms. This specifically is vital for understanding how efficient the resistor facilitates power transfer. First, let's look at what each brand has on their BMS board. The original battery has a 2.5 milliohm resistor. Ampsentrix Pro also has a 2.5 milliohm resistor. Ampsentrix Basic, Utopia, XCAP has a 5 milliohm resistor, and PowerCell nowhere to be found. But this brings into question that why not use a smaller resistor? So the latest SN7037 model uses a 001 resistor, unlike most aftermarket products using a 005 resistor. The difference stems from advancement in the gas gauge IC. The newer ICs, with improved design, can function effectively with smaller resistors, unlike older models. To better understand the role of resistors in battery circuits, let's apply Ohm's law, which states V equals I times R, where V is voltage, I is current, and R is resistance. Here's how it works in practice. If the current is coming in at 10 milliamps and the resistor or resistance is at 5 milliohms, then voltage can be calculated as 0.01 amps times 0.005 ohms, resulting in voltage equaling 0.05 millivolts. Now if we change the resistor to a 1 milliohm, then the voltage drops to a 0.01 millivolts. In the context of battery technology, especially concerning TI chips, the ability of accurately reading voltage at low resistance level is crucial. Older TI chips struggled to detect voltage if it was too low, leading to some aftermarket batteries to use larger resistors. However, the new SN7037 chip is designed to function effectively with lower resistors, reducing the overall resistance of the battery. This advancement allows for more efficient energy management and enhances the battery's performance. The protection IC is a critical component ensuring battery safety. It prevents overcharging, deep discharging, and short circuits. This IC plays a pivotal role in maintaining the battery's structural integrity and preventing hazardous situations like battery swelling, leakage, and even explosions. Nearly all modern batteries incorporate some form of protection IC, but the complexity and the efficiency will vary widely. Nearly all the protection ICs in the market have the exact same function that is not any different from the OEMs. A notable difference lies in the internal resistance. For example, OEMs typically have an internal resistance of around 3 milliohms. Our research shows that almost all aftermarket batteries, including brands like XCAP, PowerCell, and Utopia, use the SS83AK protection IC, which has an internal resistance of 16 milliohms. Now in contrast, Ampsentrix Pro uses the same protection IC as OEM, which is much lower internal resistance of just 3 milliohms. For Ampsentrix Basic, we aimed for a balance of function and efficiency. We chose the newer LP13A protection IC, which offers a significantly lower resistance of 5.7 milliohms. This choice underscores our commitment to not just quality, but also to optimizing the total power output back to the motherboard. When a charger connects to a device, three main components interact for charging: the TriStar, CPU, and gas gauge. The gas gauge first relays data about the temperature, health, and current capacity to the CPU. Then the CPU instructs TriStar to regulate the wall adapter's wattage for appropriate power delivery to the battery. These components continuously exchange data until the electricity flows into the battery at the desired rate. In the iPhone XS series and earlier models, the charging process initiates with the TriStar receiving a signal to draw power from the outlet. It then consults with a gas gauge for battery status and conveys this information to the CPU. Based on this, the CPU calculates the necessary power draw and directs TriStar to adjust voltage accordingly. This cycle repeats till the battery is fully charged. However, this system had drawbacks. TriStar was overburdened with data transmission, potentially slowing the process. Additionally, if the CPU failed while instructing high voltage, it possessed a risk. To address this, from the iPhone 11 onward, Apple introduced a revised workflow. Now the gas gauge communicates directly with the CPU about the battery health. The CPU in turn regulates power via TriStar while maintaining constant feedback from the gas gauge. If communication is ever lost, the gas gauge triggers the FET switch to halt power flow, preventing overcharging or stress on the components. In the repair community, we can see that the device's TriStar problems mostly fell between the iPhone XS Max and the older generation devices. This innovation not only addressed TriStar-related issues prevalent in the older models, but also enhanced the overall power management, efficiency, and speed. First, let's connect the original battery to the power supply. We observe that it draws only 0.6 amps of power. This consumption level is due to the FET switch functions as a diode, consuming only 0.6 amps while rejecting the remaining power. This indicates that the CPU's handshake hasn't occurred, prompting the battery to cut its power intake. When we connect the Ampsentrix Pro, it similarly draws only 0.6 amps from the power supply, suggesting that Ampsentrix Pro also supports the CPU communication. On the other hand, connecting the Ampsentrix Basic, it draws 2.5 amps of power. This indicates a lack of communication between the CPU and battery, as it continues to draw full power from the TriStar. Connecting the XCAP battery, we again notice that it draws 2.5 amps, with the FET switch failing to limit the power intake. The Utopia battery, when connected, it also draws 2.5 amps. Finally, connecting the power cell battery, we encounter the same issue. It continues to draw 2.5 amps of power, not reducing the power intake from the supply. It appears that only Ampsentrix Pro and original batteries have the capability to control the incoming power, a key feature in distinguishing Ampsentrix Pro line. The FPC connector is a critical interface between the battery and the device. It ensures stable and efficient electrical connectivity. If the FPC connector on the battery is too big, it will put stress on the motherboard and cause it to deform and lose connectivity after a short period. While FPC connectors are universally used, their build quality, precision, and reliability vary significantly. Many imitation FPC connectors are available from various factories in China. The key difference between these factories lies in the tolerance for variance, which refers to the potential difference in quality and specification from one production batch to another. Now, if we look at the original, these are the original specs of the original FPC. And when we look at Ampsentrix Pro, we can see that, hey, there is no difference between Ampsentrix Pro and the original. Now, comparative to Ampsentrix Basic and XCAP, they both seem to have a slight difference comparative to the original, but it's not very much noticeable. On PowerCell's example, we do see a significant difference, where there is a much higher difference in not only the total size, the bottom and top clips are significantly larger. And the Utopia battery has a very big difference in the overall size, and the top and bottom clips also have a much higher difference in size. Both these PowerCell and Utopia battery will cause a little pressure in the long run on the motherboard. So as you've seen, Ampsentrix Basic isn't really basic. I mean, it's the best product that's being offered by any supplier when it comes to aftermarket. Yes, there are some differences between Ampsentrix Pro and Ampsentrix Basic, but we're still offering both lines. I mean, Ampsentrix Pro is for the shop owner that's really committed to ensuring that they give their end client the best quality. And Ampsentrix Basic is for the consumer that's looking for a more competitive pricing, but still doesn't want to take a risk on putting a bad quality battery. So I understand some of these points were very technical, and not all these points are going to be easily relayed over to the end consumer. But the most important thing is that as long as the shop owner and the techs, they all understand what the differences are, they can feel more confident on standing up more for the product which they're installing in the device, and they can rest assured that, hey, that a product that a competitor has is going to be subpar to the product that they're installing. Ampsentrix Basic isn't only focused on looking for the best price. One major thing that we've seen is that every competitor since Ampsentrix has been out has brought in a product that is going to be saying that they're 50 cents or $1 cheaper than Ampsentrix. And Ampsentrix has set the bar for the market price for these aftermarket batteries. But as we can clearly see that none of these batteries, very confidently say that almost no battery being offered currently right now is close to Ampsentrix Pro. But everyone decides to price their batteries at the pricing of Ampsentrix with a 50 cents or $1 cheaper. This is one thing that drives MobileSentrix crazy, that hey, how can you carry such a low grade product and then just because you branded it, your own company name called it to be at par with Ampsentrix Pro. So Ampsentrix Basic is going to kill the price. Ampsentrix Basic is clearly priced at the actual price where this product needs to be at. And I can almost guarantee you Ampsentrix Basic kills all market prices where all the other distributors have been price gouging the shop owners just so they can compete against Ampsentrix Pro. This industry has gotten much more comfortable and open to opening up the BMS board. You can clearly open it up and see where the differences are. I hope some of these points can expand your knowledge on batteries and where you can go back in and question a wholesaler or a distributor by saying the pricing you're offering and the quality you're offering isn't up to par. We're hoping that this industry does move forward, and we're always looking to make Ampsentrix better. Over this next period of time, as we discussed that there's some parts like the winding or the stacking battery, we're continuously going to be looking to improve any one of these batteries as we can. And with the support of all the shop owners that they've given us, we're sure that at some point we will be more and more confident on saying that this aftermarket product is the same or if not superior than one of the older generation products being offered by the OEM. I'm not saying that at some point we're going to be better than OEM. The truth is that the technology that was made for iPhone X, it stopped at whatever the available technology was back in 2018-19. But as time goes on, the industry does get better. The technology does get better. And we have the advantage in this aftermarket realm to actually bring the newest technology to the older generation. I know it's been a lot to digest. Ampsentrix Basic, it's gonna bring in another opportunity for stores to offer a secondary battery at a more competitive price. We're so passionate about the products that we sell that we can't wait for you to try it. Thanks for supporting Ampsentrix. Have a great day.